Oh, Thomas Olivier is your first name, Léautier. Sorry, I won't butcher that.
Right.
From the Toulouse School of Economics.
C'est Gaulier, ouais, c'est chrétien. Ouais. Okay, I have a problem with this presentation. Hopefully it will sort itself out at some point. So I'm delighted to be here. As a rule, if you want to ask questions during the... Is that working well? Yes. If you want to ask questions during the talk, it's maybe a bit easier rather than wait for the end. There's something wrong with the PowerPoint. I think the file is too big, but I'll put it up afterwards. It's working better. So...
One second, sorry. Can you go full screen?
No, because it won't move.
Ah, okay.
I think I'll go full screen from page 3.
Okay.
I don't know why. It's just, there's a glitch in the matrix. This thing is not working. Right. But I'll promise you I'll go full screen afterwards. No, I'm delighted to be here. I do a lot of work on electricity markets. And one of the important parts of electricity market, of course, is carbon pricing. So what I'd like to discuss with you is it's really downstream from what you've been discussing before. It's really when you want to control carbon emissions, when you want to limit carbon emissions, what are the tools you can use, what are the different approaches you can use, and what are the pros and cons and how they work. So it's very much applied, it's very much trying to set up institutions to achieve the desired outcome. And as I said, feel free to interrupt me. I think it's sometimes easier. So, alors, so I think from now on I can go full screen. The matrix allows me to do that. It doesn't. It does. Okay. So what's the I'm sure you've seen that picture a million times. So emissions reductions between 1990 and 2050. In Europe, this is the plan from the Commission. And you see that electricity, which is a sector I work in, is going to be the biggest contributor to emissions reduction. I'm going to use carbon and CO2 interchangeably. I understand they are not the same thing. I understand there's some hydrogen atom linked into that. I'm an economist. I get excused for that. So the power sector can be decarbonized. Hence, it's a very important thing. Okay? So that's the policy. Now, what's the problem? Why do we have a problem? I'm going to expand a bit on what Stéphane described before. How do markets work? You have a supply curve, which is the marginal cost of producing goods. And by and large, we believe the marginal cost is increasing because it's a bit more expensive to produce the next unit. You have the demand curve, which is the marginal value that people put on buying goods, and people believe that the demand curve is decreasing with price. If an iPhone costs 1,000, you're going to buy maybe 1,000. If an iPhone costs 50, maybe you'll buy 1,000,000 because it's cheaper. And by and large, it's working out. Supply and demand, and there's only one price, which is the intersection of supply and demand. And the price gives you a quantity, and the quantity balances supply and demand. You get the right price. Important thing, the price in the market is determined by the marginal valuation. So it's the marginal valuation for the good, and it's the marginal cost of the good that determine the price, right? So those guys here, they produce cheaper than the price. They make a profit. Those guys here, they could have bought an iPhone for 1,000. They buy it for 50. They're happy. They get a surplus. Okay? Now, the problem with carbon is that there is an external effect. So an external effect is, as you know, I drive my car, so I have to pay for the cost of the fuel, but by driving my car, I emit a bit CO2, and that effect, I don't take it into account. Somehow it's not showing up in the cost of fuel. So by consuming something, I create a negative externality for other people. And that's the kind of problems that CO2 creates. And the data for that, I mean, you know that much, much, much better than I do. But essentially, the more CO2 you put into the atmosphere, the more you increase the temperature, and that has a cost. Okay? Stating the obvious, but, So that's the basic justification for the intervention to the market. So I want to do that graphically. This is the cost I pay for my fuel or for my consumption, but in fact, there is this external effect that comes in. So the market leads me here, right? Intersection of supply and demand. I drive a lot. But in fact, if I was taking into account the real cost of my consumption, I would get to this place. So that's the market equilibrium, and that's the optimum. So essentially, we consume too much carbon compared to what is optimum for society because we don't have the right price of carbon into our consumption. Okay? I mean, it's just stating the problem, right? Even in economics, we kind of state the problem before we try to resolve them. So. Now, there are lots of complicated issues that I have no clue about. And you guys know better, much better than me. What is the impact of a temperature increase? Are we going to flood China or not? I have no idea. What technical progress can be expected? I have no idea. I mean, can we find ways to move people without carbon? I have no clue. The stuff we know more about, but actually I don't know much about. I know really about this. But the stuff is, what is the cost of temperature increase? If you flood China, how much does it cost you? I think by and large, we can figure that out. What is the cost of decarbonization? And the Stern review that Stefan mentioned had a lot of numbers of, you can do this, do that, this is how much it costs. The discussion we just had, what weight for future generation versus current one? The discount rate is really how much we value tomorrow versus today. And as you could see from the previous discussion, it's not a completely straightforward topic.
Excuse me, you said that you could be interrupted.
Sure, absolutely. It's a free country.
One question.
Go ahead.
How is it possible to assess the cost of something for which you have just said that physically you are not able to describe it?
I mean, I also said at the
first line, you say you cannot state what is the physical impact of temperature increase, and then you said that nevertheless you can associate the cost with it. I don't understand what is the reason behind that.
I mean, just to be very clear, what I said up front is that none of those stuff I have the answer. I turn to smart people like you to sort those things out. The only thing I can talk to you about is once you agreed on a target, how can you make it happen? I have no clue. I mean, I'm exaggerating for effect, right? I could read as much as you do, but by and large, this takes really smart physics and stuff like that. What I'm going to focus this conversation is, once you agree you have too much carbon and this is how much it costs you, what do you do to make it happen? And the only point I wanted to make is that those are hard problems to solve, and those are really, really hard scientific problems. I mean, it's not easy. The markets part that I'm going to describe to you is straightforward. But just remember the discussion on the discount rate. I mean, those are pretty smart people, right? I mean, Stefan, of course, but Nordhaus, all those guys, Arrow is one of the leading economists. I mean, those are smart people that I do not agree, right? So it's a hard problem to crack. Once you've said that, I'm assuming that somehow you know what you want to do with carbon. Right? I live in the wonderful world of ideas. Well, you give me an answer, you say, we want this much carbon, we have a budget, or we think, the price of carbon should be X. I take that as a given. The question I'm going to try to discuss with you is, how do you make that happen in society? What kind of institutions you put in place so that it turns out? Okay. So my goal, somehow you tell me, we know what we want to do, so I'm going to try to help you make it happen. The first solution is direct command and control regulation. So you say, no car shall emit more than X gram of CO2 per kilometer. No building shall consume more than X kilowatt hours of energy per day, per week, or whatever. This I'm going to call communist utopia. The information requirement for this thing to happen is just tremendous. Right? Because you have to be able to know each consumption act, or at least the big ones, and be able to measure them and control them. And then you have to have the police go after people. I mean, it's very, very complicated. It's theoretically feasible, but the information requirements is tremendous. It may work when the pollution is very limited. So if you have 2 or 3 big facilities that cause 90% of the pollution, you may be able to command and control them. But the pollution we are talking about is very dispersed, everybody's polluting, so the command and control approach will not work. So what we try to do is incentive regulation. So there are 2 parts to that, and as I'll try to convey also how they are contradicting each other, but part number 1 is you try to price the bad being the opposite of the good, right? Pollution is the bad, and you try to give a price to it, and by giving a price to it, you will modify people's behavior. That's called incentive regulation. So instead of controlling each and every one of you, I'm just going to put a price out there, and you will adjust your behavior in response to that price. And the second one is I can subsidize and give incentives to R&D. So I'm going to talk a lot about this one, and if we have a bit of time at the end, I'll tell you why that one is bad for this one. So first thing is the tax. We talked a bit about it. It's called the Pigouvian tax after, I think Pigou was 1930? 1930. Yeah, I wrote about it. Yeah, so it's Pigou. And he says, you know, this is the problem, this is your private marginal cost, this is your supply, this is your social marginal cost, and there's a gap between the two. The simple solution, you put a tax. Boom. So, put a tax, and all of a sudden, if you put the tax at the right level, because people, you know, when they'll build something, you know, they'll realize they have to pay the cost plus the tax, so that will make the good more expensive, and you'll get to the optimum. So the equilibrium with the tax will be equal to the optimum. Okay? Taxes are great. Taxes, just put a tax out there. And you know, people. So that's the Pigouvian solution at before the Second World War. Yep.
What do you do with the income of the carbon tax? Do you just find the money, or do you do something with the tax?
The theory is mute at this point. No, as usual, you get the tax, and then the theory says you should use the tax to the best social use, which is, you know, you have the list of all the expenditures that the government could make, education, health, whatever, and the principle should. Sorry?
Nothing to do with the problem. What problem is to.
No, there are two problems. There are two different problems. Problem number one. No, let's be clear. Problem number one is how do you reduce consumption of carbon? So to do one solution is you create a tax, and then problem number two is what do you do with this tax? Economic theory tells you should use, the economic theory tells you government money should be put to use to its best use regardless of its source. So we should not allocate a specific tax to a specific usage. Let me take you an example. Suppose the real problem your society has is schooling because schools are really bad. You're going to take the carbon tax revenues and put them against school. If in another country the real problem is health because the health system is really bad and people are dying, you're going to put the carbon tax money against health. So the notion that sometimes you hear that you should use the carbon tax money to subsidize R&D and so on and so forth in carbon reduction doesn't make sense economically. It's very politically expedient, but from a pure economic perspective, if your real problem is school, that's where you put your money. Does that answer the question? Good. So that's a carbon tax. Now, second approach is something about tradable permits. This is a guy called Ronald Coase, maybe not the right word, a gentleman called Ronald Coase, got a Nobel Prize in economics for this particular notion. And this is something that has been discussed a bit in the literature, and it's worth discussing it. What Coase says, he says, instead of putting taxes, all you have to do is to create property rights. And for economists, it was a big, big deal. Because what he says, look, instead of putting taxes, here's what I'm going to do. You want to pollute? Fine, you need to have a permit. That permit is going to be tradable. So the permit is really a property right that gives you the right to pollute. And I know it's sometimes counterintuitive, and sometimes when you listen to the radios and you read the left-wing newspapers, as I do, you know, they scream a lot about the right to pollute and blah, 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 blah. But from an economic perspective, economists are pretty, it's a hard science, right? I mean, it's hard in the sense of hardened science. From an economic efficiency perspective, it makes a lot of sense. If you want to pollute, you want to have the permit. So the permit you will buy in a market. The permit will have a cost. So when you want to emit a ton of CO2, you'll take into account not only the cost of whatever the fuel you're buying, but also the cost of the permit you need to hold to pollute. Yep.
From what I understand, this was successful concerning the sulfur emission.
Absolutely, in the United States.
Then it's not only the market. You have to have a federal state who looks for non-cheating
you know, in this process. If you don't have a regulator, then everybody can cheat. How do you do it?
Treating is bad. I agree with you.
No.
Yeah, just like, I mean, in the same, it's close to the command and control. There is it's a command and control plus adjustment. And you just said previously that command and control doesn't work for this kind of issue. So how do you mix the two positions?
It is. What you say is that it's close to command and control. It's slightly different. You have to monitor that people who are actually polluting do have certificates. So in a way, you have to go and make sure that that power plant that's emitting CO2, that's burning coal, has enough certificates to match its pollution. But it's much easier than just regulating exactly how many tons of CO2 that power plant can use.
But that's the first step.
And the second argument in favor of that is that command and control, when you say, you know, those are the rules, how do you adapt when technology changes? How do you, let's say that, how could I put that? Let me put it another way.
In Europe, it began with a one-to-one discussion on how many tons of CO2 or CO2 equivalent each site could emit. I mean, it began with a one-to-one discussion with 10,000 people. So it's command and control.
It's different because if you decide, the difference with that method is that if you have, it's the Batman curve we discussed. This thing tells you we want to produce no more than 1,000 tons of CO2 per year, right? So each actor in the economy is going to decide how much CO2 they want to produce and pay the permit, or if they can reduce their CO2 consumption because they insulate their house or because this and this and that, all of a sudden they have permits to sell. So this gives incentive for people who can reduce their consumption of the bad, reduce their production of the bad, to actually do the stuff they need to do to reduce their consumption of the bad. So this is a very virtuous thing, is that it's in a dynamic. Command and control, you just set the rules and you let them free and you set the police to go and make sure that the widgets are built according to the specification. This thing is dynamic.
But you said the police.
No, you said the police only exposed, but it's exposed.
But in
But
France, you have these DREA that go to each site and control what happens. So it is command and control.
okay, let me put it this way. I think it's control. No, it's a good point. It's a very important. I think because it's the core of it. You have to control that people do not. So you put sensors on big installations, and you have to control that people do not consume more CO2 than they have permit. So you do have control, but you do not have the command part. Because then the people do. You know, if I'm really, really good at optimizing, I can change my my behavior.
Yeah, at a certain point, you will make the assumption that the invisible hand of the market will provide the coordination that the command is not able to provide.
Well, you help the invisible hand by getting this is precisely the point. If you let the invisible hand go, you'll be here. You help the invisible hand by saying, you know, this is the quantity. But then after you, then
Still need the invisible hand at this point.
you always need the invisible hand.
And if it does not exist,
But if it doesn't exist, we are really in trouble. Trust me. No, but at the end, no, but that's the point. You set the rule. You say, okay, we shall not produce more than 1,000, and then people will do the stuff they need to do to stay within their budget and trade in the secondary market and so on and so forth. And to your point, this has worked very, very well in the United States for the SOx and NOx emissions, where over the course of the 1990s, the late 1990s, it was Bush 1, they really reduced their SOx and NOx emission, and they got to stop the acid tax. Okay, so we have two approaches. Which one should we choose? First of all, before we get there are lots of issues to address. Number one is the polluter must pay. So who should be paying the tax, if tax there is, or who should be paying for the bad? Should it be the producer or should it be the consumer? In the end, it's always the consumer that pays, so that's a nice question, but in reality, if it costs more to produce, it will find itself in the price you pay, so you'll end up paying for it. Now, the two issues are, if you set a carbon tax, who is in charge? How do you calculate that? And then the question about how do you receive the cash and what do you do with the revenue, which is a question you asked before, but the question is how do you calculate the tax? And you've seen from the previous conversation that nobody agrees on the right amount of the tax. right? In different countries, depending on the discount rate assumption, you can have a tax that goes from 1 to 1,000 euros per ton. If you have tradable permits, how many allowances do you issue? I say, we get the quantity. If they are you going to have people buy them, or are you going to give them for free? And again, if you sell them, what do you do with the money? So there's a bit of theory that helps us choose between the market versus tax. And it's due to Weissman. It's a very famous 74 paper. I think it was written in another context, but it got a new life as we talked about that. And again, if we knew exactly what the benefits and the cost would be, there'd be absolutely no problem, right? We knew the demand, we knew the social marginal cost, boom, we set the optimal quantity, or we sell the optimal price, optimal tax, same thing. So under certainty, there would be absolutely no need to worry about anything. Both methods would be equivalent. Now, what Weissman shows is that the thing that matters the most is the uncertainty about the demand. So he says, look, suppose, so I'm going to fix a quantity Q star. I expect demand to be here, but in fact, demand turns to be a bit higher, right? So the demand turns out to be here. So what I would have liked to consume is actually this Q star star. And if I consume this Q star star, I would have all this surplus, which is what is between the supply curve and the demand curve, would have been my surplus and would have been nice. But because I set my quantity at Q star, I'm not getting that consumption. So I have a loss of surplus. And that's the loss of surplus if I put quantity regulation. Because I wanted to consume Q star star, and I consumed only Q because that's the quantity I set, and poof, this is my loss of surplus. Now what happens if I do price regulation? Again, I start from P star, Q star, my demand is higher, so because my demand is higher, I would have left to consume here, tac, and get this surplus. But in fact, because I consume at P star, my people are going to consume more than they need, right? Because they consume using this price P star, so they're going to be here, so which is more. So this is kind of a surplus loss. And the welfare loss is this one. And then you can see that depending on how this thing is shaped, this triangle is going to be bigger or smaller than that triangle. In fact, for those of you who are geometrically inclined, if the slopes are the same, both triangles are the same. If this one becomes more sloping down, this triangle is going to become bigger, this one is going to become smaller. And symmetrically, if this one becomes flatter, this triangle is going to get big, that triangle is going to get small. So you say that, if the demand curve is very vertical, this triangle is bigger than that triangle. So this triangle, which is the price one, is smaller than that triangle. So the Weissman paper says, the discussion about prices versus quantity regulation is a regulation of the elasticity of the demand versus the elasticity of supply. So those are theoretical papers in the 70s. Now in practice, I don't think that's the issue. In practice, I think the issue is a political economy of the setting the tax and the setting the policies. What you've seen in Europe, whenever the government sets a tax or whenever the government sets the quotas or sets the quantities, as you can imagine, it's a process with lobbyists going and saying, the tax should apply to me, but should not apply to me, but should apply to my competitors. When you said about quotas, the quota said, the quota should really be given to me for free and not given and be paid for by my competitors. And really, our industry is very, very, very different, and we employ a lot of people, so we should get an exemption from the system. And if I tell my mother-in-law to do something, will I get an exemption? If I tell my nephew who lives in Beijing to do something, I'm not kidding. I'll give you an example of why that happens. So the problem, I think, is more of a problem is which mechanism is more robust to political influence than the theoretical thing about the size of the triangles. And one of the challenges we have in Europe, which they didn't have in the US for the CO2 thing, for the SOx thing, One of the challenges we have in Europe is that the political economy, the way the system has been designed has so many exemptions and so many caveats and so many this and that it has lost completely its efficiency. And I'll give you examples of that. Be that as it may, in Europe, we've decided to go for the cap and trade system. A funny story about that. The cap and trade decision was made after the conference of Kyoto, where the Americans actually insisted that we use a cap and trade system on the back of the success they have had with the cap and trade system for the SOx and NOx in the US. So they say, if you want to control a pollutant, cap and trade is the way to go. So they insisted we did that. As you can imagine, it's not very European to go with a cap and trade as opposed to a tax system. We're more comfortable with taxes, But anyway, we went to the cap and trade system, and funny enough, the Americans did not adopt that. So they saddled us with the cap and trade system. So we have a cap and trade system. So how does it work? So there were 3 phases. Phase 1 was a trial phase from 2005 to 2007. Then phase 2 was the first real phase from 2008 to 2012. And as of last year, we entered into the phase 3, which will end in 2020. And if you remember, I think it was a couple of weeks ago, they issued some guidelines on 2030, which is presumably the phase 4. Okay? So we set a binding cap. So we say, the emissions should not exceed a certain level. Permits are allocated to polluters, and I'll give you examples of how this are allocated by country and by industry. Emissions permit can be traded. And that's the beauty of this thing. If I have a permit and I don't need it, and you need one, I can sell it to you. So if somehow I'm semi-smart and I'm able to reduce my production or to reduce my consumption, reduce my pollution, I have an extra permit, I give it to you. You, on the other hand, for reason X, Y, and Z, you need to pollute more because you need to produce more, you have more clients, you plan to expand, whatever, you can buy a permit from me. And you can either buy from me or you can buy from a wholesale market. And there's a very nice cost theorem, which is actually very powerful, and you got the Nobel Prize for that, says, whatever happens is independent of the initial allocation. So no matter how you allocate the permit initially, again, it's in market of frictionless and so on and so forth, which never happens, but still the theory is interesting. Regardless of how you allocate the permits, the permit will find their way to the people who need it the most. Which is kind of makes sense, right? Because at the end of the day, you're going to make decision based on what you need the permits or not, and whether they were allocated to you at the onset or not is not really important. Of course, it has a wealth effect. And the polluters are not permitted to emit more than the initial allocation, so you have the police that comes and, in fact, monitors your consumption. And that's actually pretty straightforward to do. So what do we expect? Well, the beauty of the cap and trade system is the cap part, right? You can say, by 2020, we'll have emissions 21% below the 2000 level. And because I fix the quantity, I can set that, right? For the power sector, we agreed to, so initially the allowance was given for free so that people don't complain, blah, blah, and progressively you start to auction them off. And now you auction them off for the power sector as of 2013. And progressively you get them out for the other sectors. And the final point is we wanted to include the aviation sector, but that didn't happen when we tried to include the aviation sector. So at some point the Commission said, look, whatever plane flies into Europe will have to pay to have the certificates, because if you fly over Europe, you will emit CO2. Therefore, you will fall under our jurisdiction, and you'll have to have certificates to show us how much CO2 you have emitted on your flight across Europe. So they tried that, and then all of a sudden, China said, well, if that's fine, but if you do that, we don't buy any more Airbuses. I'm not kidding. That happened, and we stopped the plan. And this is true story. Such is life. Airbuses, the planes. So allocation, So people sat down and they agreed, and I don't even want to know how the sausage gets made, but they essentially made an allocation based on the different industries. They made an allocation based on the countries, and you don't want to know how they got to those numbers. It's more or less based on historical production, but what do you want to do, so on and so forth. But they got to an allocation initially. And you see they want to reduce from phase 1, phase 2, phase 3, you get to 21% reduction in emission at the end of the first phase. The little blue thing was the air companies. It got scrapped. We left it in to show that reality sometimes is different than what you expect. So other points that are important, I mentioned flexibility. So flexibility means that if you have an allocation you don't want to use now, you can bank it. So you don't need to use that today. Maybe you keep it for tomorrow. You can borrow. So you can actually buy short. That is, you sell short. That is, you do not have the allocation. Say, okay, well, I don't have it today, but I'm going to pollute, and I'll promise to buy it tomorrow. And you have credit offsets, and this is what I was talking to you about. If you plant some trees in Brazil, in the Amazon forest, you get some credits. So you get some tons of CO2. If you do some particular joint implementation projects in developing countries or in Eastern Europe or something like that, you also get credits. So what I want to really point out is that what you have is a general mechanism where you say those are the rules, and you see the quantity, and then you allocate those credits for free to people, and then you give them an opportunity to get credits from somewhere else. So it starts to be a bit complicated, and as a result, here's the price. So that's the price for the ton of CO2, first in the first phase, and now in the second phase since 2008.
Euros per ton.
And those are euros per ton. Yeah, there's no units, I'm sorry. Yeah, those are euros per ton, and those are the I think it's monthly data.
We see a big increase at the end of phase 1.
So a big decrease at the end of phase 1. No, okay, so there are two things, because the first question is, why does this thing goes to zero at the end of phase 1? Well, because they realized at some point somebody did the math. We can actually say where somebody did the math. It was here. And realized that the eastern countries had more credits than they had production. So when they joined in the euro, they came in with a big industrial base, big polluting base, and people were expecting the emissions to continue. And maybe there was fraud, I don't know what it was. But be that as it may, at some point somebody did the math and said, look, there are way more permits than pollution will be. And because we cannot trade or permit after the end of phase 1, the permits that end after the end of phase 1 have absolutely no value. And because there are more of them, the price goes to zero. So there are 2 points. One is that if you do not allow, this is the sort of the boundary effect, right? That is, if you do not allow trading over periods, there's no residual value, and therefore the values goes to, in that case, zero. And the second point is that if you give too many credits, or if you get it wrong in the initial allocation, because you give way too many credits, not so much on how you allocate them, but on the total amount that you allocate, if you get it wrong, the price will come down. So the same way that the discount rate models is very sensitive to the assumption, the efficiency of this thing is very sensitive to the initial volume you put in. Because if you put too big a volume, the price will come down. Yep?
Isn't it true that there are 2 mechanisms by which the price can go down? I mean, you have an objective, and to realize this objective,
Yeah.
you give allocation.
Yeah.
If you give too much, then it goes down, you understand that.
Yeah.
But then, if the objectives are fulfilled, isn't it true that then it should go down also?
No. It should reach the equilibrium price. Because at some point there will still be people, there's no guarantee that the equilibrium price is zero, right?
This decrease.
No, we don't know where it is.
Second phase. How do you explain this decrease?
Okay, so the second phase.
Recession.
Sorry?
Recession.
Recession. The second phase. So now the second phase starts high. So people, the marginal value of a ton of CO2, that is the marginal cost for people to abate, or the marginal value for a guy to consume, starts at about 28, 30. And then all of a sudden, this is the economic recession, which reduces demand for electricity. This is the sector I know best. I don't know about the rest. But demand for electricity in 2008, on average in the euro, minus 4%. And that's mostly driven by industrials. So that's the recession. So all of a sudden, people need less CO2. They produce less, so therefore they need less permits. This is the recession. And then it overshear, and then it continues to go down as the industrial production goes down.
But the objective is still fulfilled.
Okay, that's the point. That is a great point. The question is, does that work or not? Now you have the objective is fulfilled because we reduce our consumption by 20% compared to the value we had set up. So the quantitative objective is fulfilled. Now now let's continue because this is really but that's exactly right. Now the problem with this, as usual when you have a price, there are two things that happen with a price. The price has two roles. One is just instantaneous consumption. So yes, the quantity does the stuff for us, so we consume less CO2, and the price settles that. The second is investment incentive, right? Because the important part is that if the cost of CO2 was 30 euros a ton, I would have strong monetary incentive to put, I'm going to use the word scrubber even though it doesn't apply, but to do carbon capture and storage at the end of my coal plant. Because every ton I can save, I save 30 euros. So the higher the price, the higher the incentive to develop clean technologies. With a price at 4 euros, nobody is going to spend money to reduce their carbon consumption because it's just too low. So to respond to your question, you realize the first objective, which is reduce consumption. Well, actually, the recession does that for you. But yeah. So another way to say that is, what? The price is right. The price reflects the supply and demand condition. Demand is very, very low. The price is low. So let me just finish the demonstration. So that's right. But the second objective, which is to incentivize investment, that is give incentives to people to go and clean up their production process, to put capital in the ground so that tomorrow they produce cleaner, you don't get at that level. Sorry, question?
Carbon dioxide emissions are rising. At least in Germany, it has been rising since 2011.
Absolutely.
So isn't the main reason is that we had too many permits given for free, the grandfathering at the insistence of Germany? Isn't that the basic reason why the price goes down, although the carbon dioxide emissions are going up? You could
do it. It's the thing about the glass half empty, half full. The glass half full says, we produce less and so on. The glass half, essentially we were expecting an economic growth of 1 to 2% a year or something like that. So we're expecting a growth in emission. Growth being flat, the emissions are flat or go down. On average. Now, that's, it's like entropy, right? Entropy is, for the entire universe goes up, but it could be pockets where bad things happen. Here it's the same thing. The total emissions go down in the world, but they go up in the German power sector.
Okay.
Yeah. Yep. The new market. New market, because they didn't allow the market to continue, so they say. Oh, there were a bit. I don't think people are making that much money. Well, there was a bit of fraud and so on, but no, it's two different markets. To answer your question, it's two different markets. So there's no arbitrage. You cannot precisely. That's the point. If you could arbitrage, this thing should be continuous, right? If you could take that unit and sell it there, the price should be continuous. And the discontinuity is really because there are two different markets. You couldn't take your emission phase 1 and trade it in phase 2. Yeah, they just disappear. They expire. They die.
And the new ones were not sold. They were again handed out. No.
But in the new ones, some of them were handed out and some of them were sold, and the power sector starts to get progressively they sell more and more of them. Other questions on this one?
When they were sold, who got the money?
The government got the money. But it's still, it's small compared to, it's small. Yeah.
We need incentive for investments. And
Yep.
I don't know, as an engineer, building any technology with such a failure would be just immediately discarded. Why can't, I mean, what I'm surprised that in the energy field, there is a strong inertia. So when investment is made for 20 years, and just to get market period such short like this one, and repeat that with a change, how can it be made feasible? I'm really stuck.
Okay. Yeah, that's the challenge we have, I think, in this industry is that there are too many instruments at once that makes the price unpredictable. And you're right. It's very difficult to commit to a long-term investment having this volatile price. Now, what some countries have done, in particular the United Kingdom, I say we do not want to be it's actually very strange because Britain invented capitalism and markets, but still. They are the one who came with the idea that we do not want to be subject to the vagaries of market prices, and we're going to fix a carbon tax, and people will pay the carbon tax, which is 20, and we refund them whatever they paid for their certificates on the market. So you want to, some countries are saying there's too much uncertainty in this price, and therefore we want to fix the price level so that investors can invest. It's age on debate. Yep.
What was the total amount of the market?
I think it was 2 million tons. Could be wrong, but I think it was, was it 2 million tons per year? I had the number somewhere. I mean in tons or in euros? Actually, it's a good question. I don't know. I've looked at the price. I don't know what the volume is. I'll find it out for you. It's not a big. It's a few billions. It's not the dollar exchange rate. Yep.
I come back to my first question. You say there is two objectives. One is to limit the quantity of commodity to be emitted, and the
Yep.
second is to make the right investment.
Yep.
But basically, there is one big objective, and the second one is a consequence of the first.
One is a static one. The other one is dynamic. Because you make the investment today, you will have less consumption tomorrow.
Yeah, but I mean, the incentive to make good investment is needed.
Just hang on 1 second. We're trying to record so people can watch this later. And so the quick clarifications, when he then clarifies, that's okay. But discussion, we're going to have to wait till he's done. So do you have any more else to talk about? Or?
Yeah,
Is there another thing?
No, there's.
Otherwise, we go to the discussion. And then you need to use a microphone.
Well, we can do it both ways, right? I have a model. I have a few equations. If you want to see equations.
Okay, keep going.
Yes.
You got 5 more minutes.
Okay.
No interruptions.
I know, it's up to you. So I think the interest for you is just to see how economists view models, and it's kind of cute. And trust me, it's not hard. And that sort of formalizes a bit the discussions we are having. So this is you produce using a bad, so for example pollution, and you sell your good at price P, and you produce quantity Q, and you consume the bad X. The cost of X is omega per unit, and you can also decide to reduce your consumption, and it costs you G per unit of abatement. Abatement is, you are going to consume less unit of X to produce whatever you want. There are some assumptions on concavity and all that good stuff. The cost of abatement is increasing. That's the curve that we just saw, the McKinsey curve. The cost of abatement is increasing, so it costs you more and more to abate, and it's convex. So it costs you more to abate the higher you need to abate. And what you pollute is X, which is what you consume, less Y, which is your abatement. Okay? So economics model have this nice property. They are very simple. So the first order condition, well, in that world, there's no gain to you abating, right? Because the abatement is costly, so you're not going to make an effort to reduce your consumption. So you're going to not reduce consumption at all. So y is going to be equal to 0. And then this equation on x gives you a function of your demand for the good, which is a function of omega, the price you pay for it, and p, which is the price you're going to sell your stuff at the market. And this function has all the right properties you want it to have. Sorry?
Q prime is a derivative with respect to what?
Q is a function of only one variable. So it's the inverse of the derivatives. I just inverse this function, right? Q prime of x equals omega over p, and I just, because Q prime is decreasing, I can, it's decreasing, I can invert it.
dq dx.
dq dx, yeah. Oh, yeah. There's only one variable. Trust me, it's easy. So now I put some constraints. And I put a constraint E bar, which is lower than what would have happened otherwise. And now, because I put a constraint, all of a sudden, I can buy and sell permits at a price PA, which is an exogenous price. As I'm a price taker, I do not manipulate the price. So my first order conditions, now my problem is a bit different. I still have the part where I'm going to make money selling my good Q. I'm going to have to buy the permits. I may or may not do abatement reduction, and I may or may not buy or sell permits. And the constraint on me is going to be that x minus y, which is my net emissions, is lower than what has been allocated to me, plus what I bought in the market, or what I sold. Right? So now you introduce a Lagrangian, which not even... and you get those first order conditions. So essentially the first order condition is that the shadow price of that constraint is going to be PA, the cost of abatement. And then you crank that into your equations. What do you see? BD. So you generate your demand. Now the point I want to make is that all of a sudden your demand for the good X is going to be omega plus PA over P. And that's an important point. When you're going to consume one more unit of coal, let's say, you're going to buy it omega, but you also are going to take into account the fact that to consume that unit of coal, you'll need to buy a certificate. So in your consumption decision, you're going to take into account not only the price, plus the price of the certificates. So in other words, this thing is working, right? Because you internalize. The objective was to have you pay the cost of pollution. What if the PA is set properly? You do pay the cost of pollution, and you reduce your consumption of coal. So we can see that graphically. That's your initial demand, the omega, and tell you, the net demand you're going to consume is going to be whatever you're going to need minus what you're going to abate minus the allocation. So I go from this X, I reduce the E, then I work hard to reduce my consumption, and I sell the residual onto the market. Okay? So that's how these things works out. Particular point is this one where actually I'm neutral. So if the price for permit, again, for me the price is exogenous, right? So I don't know, I don't control it. If the price of permit is above that, I'm going to actually buy from the market. If the price of permit is below, if the price of permit is below, I'm going to buy into the market. The price is higher, I'm going to sell into the market. Now you can have an equilibrium, and I'm going to stop there. You can show that you have an equilibrium that verifies those conditions. So this guy buys, this guy sells. The only point I want to make, the equilibrium is such that whatever people consume minus whatever they abate is equal to the initial endowment. So you sum of all the players. And you write it this way. The only point I want to make is that this thing is independent of the initial allocation. Because when you look at the formula, the initial allocation appears nowhere. And that's Coe's theorem. Because eventually people trade, and no matter what the initial allocation was, they just trade to get to their optimum. There are lots of other stuff. You can auction allowance. Now, as a conclusion, what do we think? we think cap and trades work. However, the problem is that cap and trade do not exist in isolation. The system of cap and trade, I thought I had something more like that. Yeah. The problem of cap and trade is that you have cap and trade existing with other tools. So you have one tool for cleaning. That's our cap and trade. You have one tool for greening. And the greening is all the subsidies you give to renewable production sources. You have one tool for saving, which is energy saving certificates. I'm not going to get into that. And the general view we have as economists is that those tools are competing with one another. That is, if you subsidize renewables, you're going to have a lot of windmills, which is good. So those windmills are going to produce less carbon to produce the energy, which is good. But because there's less carbon being produced, the price in the carbon market is going to be lower, which is going to reduce investment incentives. So in a way, the different tools that are being used at the same time are conflicting with one another. And
they cooperate.
Sorry?
Instead of conflicting. Why do you say conflicting?
Because if you reduce the demand, you're going to reduce the price. No, they do not cooperate. No. You reduce the demand, you reduce the price. But no, it's more than that. That sometimes in economics there are things we don't know. This one we know. If you reduce the demand, you reduce the price. That's a fact. And if you reduce the price, again, it's a good thing because presumably you could produce with less carbon, which is nice, but you have less investment. So it may be statically efficient. It's not actually because of other things with Germany and coal and so on and so forth. But it may be statically efficient, but it's dynamically inefficient. That we know for, that's sure. And that's the problem we have. So I don't know, maybe the Great Plague will sort us out, but short of that, what we have right now is a situation where too many instruments have been given to too many different people, and the outcome is really not efficient from any metrics perspective. Thank you.